We're going to continue reviewing alcohol's reactions. So this time, same molecule, we're going to treat it with a different set of reagents. What do we have here? As first, I'm treating that with PBr3, and then we have second, we're putting this is sodium methoxide, and third, we're doing cold potassium permanganate. Okay, so let's analyze again, step by step, to get to the final product. So now, reaction one. This reagent is used to transform the alcohol into an alkyl halide. And we must remember that this happens with inversion of configuration at the center. That is a chiral center. So the product of that first reaction is a bromide, but we will have an inversion of configuration at that side. So I'm going to do this. That stays the same. Okay, second step is sodium methoxide. That is, the reagent is a strong base and a strong nucleophile. But since this is a secondary alkyl halide, the predominant product is going to be the elimination product, the E2. And more decisive than Hoffman because that's a small base. So, and also here you have, remember that for the elimination, and that's again an E2, is a major product. And that we need the beta hydrogen anti-paraplanar to the leaving group in the mechanism. So let's analyze what we have here on one side and on the other side to have these sites of product that will be the more substituted. See if that is possible. So here I have a hydrogen, and that hydrogen is anti to the leaving group. So I can have that. Here you have two hydrogens. So the preferred location will be that. So let's just throw a little bit of charges here. This reagent is going to get this hydrogen in the A2 mechanism, and that will form a double bond here, and that will go. Yes, so that was possible because the hydrogen was in the appropriate conformation. So let's do the product now. We can draw it, the product of that reaction. So we have an alkene now. And there is a change of hybridization here from sp3 to sp2. So now I draw a solid line, no wedges, no dashes. Now let's analyze that third reaction. So that this was the reaction 2, the elimination, and now we're going on to reaction 3. So that potassium permanganate cold, that condition is used cold to make diols, but not any diols. So this is making a dihydroxylation. But the diols are to the same side, so it's seen. So when we're drawing the product, then we need to pay attention to that. So because of the mechanism. And so the product is dihydroxylation. So I'm going to do this too, for example, in wedges, same side as we said before. And these one of the product and the other, where you will have the two OHs to the same side. And we see here that we have inversion of configuration at the two centers. So these two are a pair of enantiomers.